So this is how you read bearings. Check out this one right here. See, it says south, 35 degrees east. So you always say north or south first. South, so you start facing downwards, so towards the south. And then you turn, which direction would you turn to go southeast? If you're facing down this way, would you turn left or right? Oh, no, like you're facing that way. So that means you would go left 35 degrees. And that would be written as south 35 degrees east. If you were facing north first, and then you go 80 degrees west, boom, that's what you would turn. Which way would you turn if you're facing north and you go west? Left. Which way would you turn if you're facing north and then you go east? Right, so that would be 45 degrees east. That makes sense to you guys?
Yeah.
Okay, now let's attack a problem that involves these. I want to start reading this problem without looking at the picture, okay? Because it is kind of confusing, but let's read. A ship leaves port at noon. That's 12 o'clock, right? Heads due west. Ooh, what does due west mean? That means exactly west. So that would be, no question about degrees or anything. 20 knots. Now that's a speed. Or you can say 20 nautical miles. All right, per hour. So he says per hour. That's how you know it's a speed. At 2 p.m., the ship changes. So how long did it go 20 nautical miles? 2 hours, noon to 2, right? So how far did it travel?
40 miles.
Okay, so I'm asking you guys lots of inside questions, like outside questions that you wouldn't think of maybe right away, right when you're reading this, but they do give us a picture to make this easier. At 2 p.m., the ship changes course to north 54 degrees west. Okay? As shown in this figure. Okay. Find the ship's bearing and distance from the port of departure at 3 p.m. So at 3 p.m., so now we're at 3 p.m. So how long did the ship travel this direction?
1 hour.
Just 1 hour. And it's still going 20 nautical miles, so that should be a distance of 20. So let's see what our picture looks like. Okay, so for our picture, we got... All right, check this out. We got our port right here, due west. That's directly left. You see our little compass right here? Directly left. And then it even tells you that's 4 nautical miles, but we already knew that, right? Right? Okay. And then the ship changes direction and starts going north 54 degrees west. See, this is the north part. 54 degrees would face us right here. And so the ship is going this way. And it goes that way for an hour, so it goes 20 nautical miles. So how would we find this distance right here that the boat is from the port? And then how would we find its new bearing according to the port? Like if I had a new ship right here and this ship right here stopped because it ran out of gas or something, what would be my bearing to go this direction? Okay, we're going to do the bearing last. First, we're going to find the distance of this line. All right, you guys ready? All right, so it took me a second to figure this out, but since, I'm teaching you guys, I can just tell you, and you guys will learn, hopefully. I don't know. Maybe you'll learn. Okay, so what do I need to find in order to find the length right there? Now, I see right away, I don't know if you guys see this, I see this big right triangle. Did you guys see that right triangle? Okay, now, if I see this big right triangle, I'm thinking, if I have this whole side right here, and I have this side right here, I can use Pythagorean theorem. For sure? So let's look over here. I have only part of this side. I know it's 40. What's the other part going to be? So I'm looking at this smaller right triangle. So that's what I'm looking at. I'm looking at a smaller right triangle. Let's draw our small right triangle. Our small right triangle looks like this. This is 20. That's a right angle. This is B, and this is D. And then, do I know anything else on this triangle? In geometry, I used to call this complete the picture.
Angles.
Ooh, I know an angle. What angle do I know?
54 minus.
Hey, 54 is this guy right here. Now, this is 90 degrees, right? Okay, so 54 is right here. What's this going to be? 36. That's right, because we do 90 degrees minus 54, we get 36. So if we have an angle and one side, can we find the missing sides? Yes. Do you guys know which trigonometric function you would use to involve those three numbers together? Cosine. So cosine of 36 degrees. Now, if you're using a calculator, make sure you're in degrees. D divided by 20. That is adjacent divided by hypotenuse. Guys, bust out those calculators. Let's go. We have 20 times cosine of 36 degrees. Do you guys remember doing this stuff? All right, so what is D approximately going to equal? Can you guys please tell me after plugging that into your calculators? So after plugging this into our calculator, we get 16.180. So I'm just going to leave it like that. That's my distance there. So I'm going to put 16.18. Okay, and now let's find the B. Now, how do I relate these three numbers together? Which trig function relates those together? Sine, because B is opposite. 20 is hypotenuse. And so I have sine of 36 degrees equals opposite over 20, the hypotenuse. And so we get 20 times sine of 36 degrees equals B. So what is B going to equal, my students? Okay, 11.756 is my B. I'm going to go ahead and put it right here, 11.756. And what is the length of this whole side now? This whole thing. It's going to be 40 plus the 16. So we get 46.18. 56. Oh, yeah, 56. 56.18. All right, so let's use Pythagoras to find the C, shall we? We shall. We have C squared equals 11.756 with a squared plus 56.18 with a squared. What do you guys get for C squared? Can you guys tell me? This is what we get for C squared. Now, what about C? Can you square root that, please? Okay, so this is what you get after you square root both sides. Don't forget to round that 6 up to the 7. So this is nautical miles? That's your distance. Okay, so how would we find this angle, though? Actually, if we wanted to find the bearing, we got to know this angle. So this is north, and we're going west, right? So we're turning west. So we gotta say we're going north and then west. But what degrees west are we going? What is this arrow going to be? How would we find that? Huh? Ooh. You guys remember that arc stuff? Arc tangent? You can use arc tangent, arc sine, or arc cosine. If you use them all to see if you get the same number, you'll get slightly different numbers each time, but that's only because we're rounding and estimating and stuff, and that's just the way it works. So we got arc tangent. I'm going to do arc tangent. And for arc tangent, I got to plug sides in so I can find that angle right here. So I'm going to find this angle, and by finding this angle, I'll be able to find this angle. Because both of these angles, they're complementary, which means they add up to 90 degrees. So what is the opposite side? It's 11.756, and then the adjacent side is 56.18. Can somebody of you guys go arc tangent of that and tell me what you get? 11.819. Does everybody else get that? That's degrees. Right? You did degrees? Some degrees? Okay. So what is this number going to be? It's not going to be this. Subtract 90 from this. What do you get? 90 degrees minus 11.819. Is that 9? Yeah. What do you get? What do you get? Is it 79? 78? No, I want the exact answer. Tell me the exact answer. 78.181. So there's your bearing. So we got our bearing and our distance.